Example 4. Create a function y equals f of x with a derivative dy dx equals tangent of x and satisfies the condition f of 3 equals 5. So in this problem, we're given the derivative and we want to create the function. So we know that the derivative of tangent is secant squared, but we don't necessarily know what the integral is. So we're going to actually use the fundamental theorem of calculus in order to figure this out. So looking at this problem, make a note that this is f prime of x, and also make a note that f of 3 is equal to 5, so then you get the point 3 comma 5. So when I plug 3 into my f of x function, I should get 5 as a result. So here we go. Using the fundamental theorem of calculus, we get that dy dx is equal to the derivative of the integral from some constant to x of tangent of t dt. This is using the fundamental theorem of calculus, and we also know this is equal to the tangent of x. So again, notice that this is equal to tangent of x, which is also equal to this entire thing right here. Okay. So we have y is equal to f of a. This means that we're evaluating the function f at a value a, and we're going to use the a equal to 3. Notice that I also strategically placed an a there. Okay, I did that because I know that I'm going to put a 3 in for x and something cool is going to happen. But remember, it doesn't matter what constant you use. So I get that the integral, that y is equal to the integral from 3 to x tangent t dt. So what I did here is I got rid of the derivative. I got rid of this derivative, and I'm just keeping the integral. This is what y is equal to. If I got rid of the d dx on both sides, I'm left with y and then the integral. So now we're going to use f of 3. So we get y equals equal to f of 3, which is equal to the integral from 3 to 3 tangent of t dt. Remember from an integral property that if these values match, then the entire integral equals 0. But we said in the previous explanation that f of 3 is equal to 5. So when we plug in 3, we need to get 5. Well, okay. So all we're going to do is add 5 to our function. So y is equal to the integral from 3 to x tangent of t dt plus 5. That's all we had to do. Because think about it. If you take the derivative, what happens to a constant? It goes away. And we have the derivative, back in the beginning, the derivative is tangent of x. There's no constant there. But when you take the derivative of a constant, it goes away. With all of this hard work, we can notice a very easy pattern. This is our y1 value, and this is our x1 value every time. So if I wanted f of 6 to equal 20, I would put a 6 right here, and I would turn that into 20. With that said, I want you to go ahead and try this one now. I want you to determine the equation y equals, given that the derivative is sine of 2x, and y equals negative 2 when x equals 5. So pause the video right now and try it out. Okay, let's do it together. First thing I want to point out is that all of this means f of 5 equals negative 2. So from here, we want to create a y equals equation. So it's the integral from 5 to x sine of 2t dt minus 2. Again, this value goes right here, and this value goes right here. And that's all there is to it.